Now we look at the implicit feedback through local analysis. We will look at method or approaches that we can use in order to analyze the implicit feedback and then get information out of there using local analysis methods. So basically, local analysis consists in deriving feedback information from the document retrieved for a given query queue. So this is similar to a relevant feedback cycle, but done without assistance from the user. So we have two types of local strategies. They are called local clustering and also local context analysis. So for local clustering, we apply or we adopt the clustering technique for query expansion, in which we quantify the term correlation and we use this correlated term in order to expand the query. So whatever terms that we have or that we found to be highly correlated with the query, we will expand the query by adding this term. Term correlation can be quantified by using global structure, such as the association matrices. However, they might not adapt well to the local context defined by the current query. So for that reason, we will use the local clustering. Okay, for the association cluster, we will define the following. For a given query queue, let D to be the local document set, which is the set of document retrieved by Q, and then N to be the number of document that we retrieve by using the query queue. And based on the document retrieved, we will look into the distinct words that we can extract from this document. And then from there, we can form the term document matrix by computing the frequency of occurrence for each of the term found in the document. So we have this frequency of term I in document J. So we can use this weightage to form this matrix called term document matrix. And then we need the transpose of this matrix in order to form what we call local term-term correlation matrix. So this term-term correlation matrix can be used to find two terms which are highly correlated to each other. So for instance, we have this matrix. We have the keyword 1, 2, 3, and also we have the document 1 and 2. We take the transpose of this matrix, and then we will perform the multiplication. Then we will get that. So this, what we call term-term correlation matrix, we can find whichever value that are high, then we can say that that particular keyword, for example, keyword 2 and 3, if this particular value is high, we can say that this keyword is keyword number 2 and keyword number 3 are highly correlated. So we can use this term, or we can use these two terms to be added to the query. So for each element that we have in this, okay, for each element that we have in this section, basically is the multiplication of the feature U and feature V in the same document. Okay, So this refers to all the document that we have in our set of document. So this weightage is basically getting the frequency of this term times the frequency of that particular term in that exists in the same document. This relationship between the term is based on the joint co-occurrence inside document of the collection. So if two terms, for example, term U and V exists in most of the document, so we can say that these two documents are highly correlated to each other. So the higher the number, the more they are correlated to each other. So we can use this to expand our query. Okay, this is the formula that we use to normalize the value, because since we are looking for the higher number, it is better to normalize the value to 0 and 1, so that it is easier for us to find which one is the highest one. So basically what we have here is we will take the previous value of the U and V for the weightage that we have, divide by the weightage of UN times U plus the weightage of V times V, and then minus the weightage of U and times V. So this one will give you the normalized value of U and V. So this is the exercise that you need to do. You need to compute the local association matrix for the following sample collection. So you need to find the transpose of this matrix and then get the multiplication. And then you normalize the matrix using this formula, the previous formula, and then determine two best neighborhood that can be found that are highly correlated to each other. And that's it for this session.